Page 427, lesson 7.2 is on multiplying powers with the same base. So again, continuing this lesson. So the bottom of 427 talks about how exponents can also be as fractions, and fractional exponents are called rational exponents. So we've talked about before, 3 squared means 3 times 3. We can also have fractions. So 9 to the 1/2 power we could have. So kind of if you think about it, if you had 9 to the 1/2 power times 9 to the 1/2 power. If you think about what we talked about yesterday, multiplying like bases, you add the exponents. That would be equal to 9 to the 1st power, which is 9. Basically, then these are both the same. If they're both the same and we multiplied them together and got 9, each one of these would have to be equal to 3 then, right? 3 times 3 equals 9. So basically then, from that, if those are equal to 3, then 9 to the 1/2 power, if you have something to the 1/2 power, that's the same as the square root of that number. And then the last thing they talk about on this page is that in general, if we have 1 over, or a to the 1 over m means b multiplied as a factor m times equals a. To put that into a plainer thing, if we mention an example, if you had 8 to the 1/3 power, that would be the cube root of 8. So it's kind of looking at whatever your denominator is, that is going to be this index we can put. On a square root, I think we've mentioned before, with square roots, usually we don't write the index there, but technically for a square root, you could put a 2 there as the index. So that's to the 1/2 power, index of 2. If it's to 1/3 power, we have an index of 3. And we can have, we'll get into this, but we could have something like that even. What will happen when we have something like that is that the numerator we can just keep with that base, and then the denominator tells us what our index is. So if we would do a problem like that, that would be the 5th root of 4 squared. Okay. We won't be getting into 5th roots and stuff like that too much here, but that's what that would look like if we got something like that. So the cube root of 8, we haven't talked about that too much, but just for your information, the cube root of 8 says I have something times itself 3 times that equals 8. Well, 2 times 2 times 2 equals 8, so the cube root of 8 equals 2. Just like a square root, we have 2 factors, like we mentioned earlier. 3 times 3 equals 9, so the square root of 9 equals 3. So some of the stuff, what I've just shown you, you wouldn't necessarily be asked to evaluate that or anything, but just so you know what that's looking like. So if you look at problem 4, they want us to simplify this expression, 81 to the 1/4 power. So the book just says, well, we need something multiplied by itself 4 times to get 81. And really what this amounts to is to the 1/4 power, we have a 1 as our numerator, so it's like 81 to the 1st power. And then the denominator is 4, that means that's the 4th root. So the 4th root of 81, again, means we have 4 numbers. They have to all be the same. We multiply by themselves to get 81. So again, that would be like they're showing here, 3 times 3 times 3 times 3 to get 81. So 81 to the 1/4 power is equal to 3. So 3 would be our answer for that problem. So let's look at the got it. So on part A, we have 16 to the 1/4 power. Again, numerator is 1, so that's just like a plain 16. Denominator is 4. That means we have a 4th root of 16. So we're thinking about there's 4 numbers multiplied by themselves that equals 16. We have to figure out what that number is. We can multiply by itself 4 times to get 16. So we can guess some numbers. You'll get better guessing as you go. But this will end up being 2. 2 times 2 times 2 times 2 equals 16. So the 4th root of 16 equals 2. Part B, we have 27 to the 1/3 power. So this would be like the cube root of 27. Cube root means we have 3 numbers times themselves, that equals 27, and that ends up being 3. 3 times 3 times 3 equals 27, so our answer is 3. And part C, 64 to the 1/2 power. So that one is like the square root of 64. Remember that 2, they don't usually write that index of 2 there. It's usually just, if there's nothing there, we just assume it's the square root, and square root of 64 would be 8. So the next part just talks about how we could have something besides a 1 in the numerator. So 9 to the 3/2 would be 9 to the 1/2 times 9 to the 1/2 times 9 to the 1/2, because if you add, like we talked about in the last section or earlier in this section, if you're multiplying like bases, you can add the exponents. So a 1/2 plus a 1/2 plus a 1/2 would be equal to 3/2. So the book's just saying, well, think about each part of this, and then the 9 to a 1/2 equals 3, so this would be like 3 times 3 times 3, which equals 27. Another way you could do this, to me an easier route, would be kind of like what we mentioned earlier. We could say this is like 9 cubed, and then we have the square root of that. So the square root of 9 cubed, and then 9 cubed is going to be a bigger number, and then we would have to take the square root of that, and then we would get the same answer. So if you look at problem 5, they want us to simplify this expression. So we could put 64 to the 3/2. We could have basically split it up, 64 to the 1/2 times 64 to the 1/2 times 64 to the 1/2. And then each of those, the 1/2, that's the same as the square root. So square root of 64 times square root of 64 times square root of 64. So that's the same as 8 times 8 times 8. If you multiply that out, is 512. And again, we could do 64 cubed and then take the square root. That's going to be a really big number. That's going to be a lot of guessing on our part. So probably just as well to do it the way the book's suggesting here. So if you look at the got it, 5. So for part A, 25 to the 3/2, this is very similar to what we've been looking at. So we could say 25 to the 1/2 times 25 to the 1/2 times 25 to the 1/2. That's like the square root of 25, which is 5. Square root of 25 is 5. Square root of 25 is 5. Multiply is 125. Part B, similar idea. We have 27 to the 2/3, so that'd be 27 to the 1/3 times 27 to the 1/3, which again is like the cube root of 27. Cube root of 27, something times itself 3 times, that equals 27 is 3. And then 3 times 3 is 9. Part C, we've got 16 to the 3/4 power. So this could be 16 to the 1/4 times 16 to the 1/4 times 16 to the 1/4. So that's like the 4th root of 16 for each of those. 4th root of 16, so 4 numbers times themselves, that equals 16, and that would end up being 2. A lot of these, the numbers are going to be pretty small, so if you're not sure, usually guessing a small number is probably the way to go. Multiply those together, which would be 8. So the bottom of the page says you can use properties of multiplying powers with the same base to simplify expressions with rational exponents. So if we multiply powers with the same base, we can add the exponents. We've already talked about that, but it still works with fractions as well. So if you look at problem 5, so problem 6, they want us to simplify this expression. Any numbers that you have, we'll just bring those out in front and multiply those. So there's a 2, 3, and 5. Bring those out in front. Multiply those as 30. Get your a's together. So we've got an a to the 2/3, a to the 1/3. Get those together. If you multiply, we're going to add those together. 2/3 plus 1/3 is 1. So that'd be like a to the 1st power, or just a. And then the b's, if you get those together, 1/4 plus 1/2, that'd be like 1/4 plus 2/4, which is 3/4. So our final answer would be 30a b to the 3/4. So if you look at the got it, so the got it part A, similar idea here. So the numbers here we can pull out in front. The C's we can keep next to each other. 2 times 2 is 4. With the C's, we're multiplying, so we're going to add these exponents together. So 3/5 plus 1/5 is 4/5. So this would be our final answer for part A. If we look at part B, similar idea. This one doesn't have numbers in front of it. So multiplying like bases, we add the exponents. 1/3 plus 4/3 would be 5/3. So n to the 5/3 for that one. If we go to part C, similar idea. This one just we have 2 different variables. So first, if you want to kind of sort these out, get your B's next to each other and get your C's next to each other. So multiplying like bases, we're going to add our exponents. So here I'm going to add 2/3 plus 4/9. In order to do that, it would be good if our denominators were the same. So multiply the first fraction, numerator and denominator, by 3. That'd be b to the 6/9. And then b to the 6/9 times b to the 4/9. Add those. 6/9 plus 4/9 would be 10/9. And you can just leave it like that. Same idea with our C's. We're going to add these, so get a common denominator. 10 would work here, so multiply the first one. Both of those by 2, that'd be 4/10 times 9/10. So 4/10 plus 9/10 would be 13/10. So we can just leave it like that. Technically, you don't have to have the parentheses when you write that. If you want to just write it this way, it's fine also. And then finally, if we look at part D, we've got some numbers once again here. So we may want to just go ahead and fish those out to the front. And then if you want to get your J's next to each other, get your M's next to each other. So these numbers, they're just numbers. we can multiply like we've always multiplied numbers. And if you multiply that all out, you should get 441. J's, we can get a common denominator of 6. So that'd be j to the 4/6 times j to the 1/6. Same thing with the m's. M to the 1/4. This would be m to the 6/4. And then if we add these together for the j's, 4/6 plus 1/6 is 5/6. 1/4 plus 6/4 is 7/4. If we look at the lesson check number 7, your friend says 4a to the 1/2 times 3a to the 1/5 equals 7a to the 1/7. Explain your friend's error. What is the correct answer? So there's actually a couple of problems here. One problem is that with the variables, they didn't get a common denominator. They just tried to like add the denominators together, which we never do. So we would want to get a common denominator, which we could get of 10. So that'd be 4a to the 5/10 times 3a to the 2/10. And then if you want to get your numbers in front here, you can. The other problem is they didn't multiply the numbers in front. They added those as well. So 4 times 3 is 12, and then this would be a to the 7/10. So this gives you an idea of how to multiply powers with the same base.